Right, we're now going to look at the geometric series, and we're looking at the sum of the geometric series. Now here, we're using the same notation, Sn. Now I can write Sn as equal to A plus AR squared, etc. Now, as you can see, they've all got a factor, they've got an A as a factor, so I can write this as A times 1 plus R squared, etc., etc. All I've done is taken the A out. Now, if I multiply Sn by R to get R Sn, that gives me A and then times R, but I can just multiply this R and put that into a factor, so that gives me R plus R squared plus R cubed plus etc, etc, etc. Now what I can do is I can say, right, well okay, right, I want to take one away from the other, and I'm going to take this term here and I'm going to take it away from that term there. And that's going to give me R Sn take away Sn is equal to A R plus R squared plus R cubed, etc. minus A times 1 plus R squared, etc., etc. Now on this side, I can take Sn as a factor out, which gives me Sn R minus 1. Okay, and if you notice over here, this is AR, or A times R squared. Now I've got an A times R here, so I can cancel this with this, and this with this, and this with this, and it carries on. So what I'm left with on this side is just A R to the n minus A. And I can take that out as a factor, A R to the n minus 1. Now, if I divide through by this, that gives me Sn equals A R to the n minus 1 over R minus 1. And that gives us our function, or our formula, to find out the sum. R being the common difference, n being the total number of terms, and A being the first difference. Now this is useful if R, the value of R, is greater than 1. Okay, remember what we were saying about earlier in the first video about it being divergent or convergent. If R, or this two lines mean the modulus, so it could be plus or minus, is less than 1, then it would be more useful to use the term 1 minus Rn, 1 minus R. All I've done is multiply the top and the bottom by minus 1. Okay, and that would be the form to use. Now I've got a couple of questions here that we're going to go through. In fact, a couple of questions that we're going to go through using this formula and what we did in the first video. So here, evaluate this. Well, if I put it, R, obviously R goes from 1, 2, 3, so Sn, which is the sum of the numbers, is equal to 3 to the 1 plus 3 to the 2 plus 3 to the 3. Now this is a geometric sequence because this is 3 times 1 plus 3 times 3 plus 3 times 3 times 3, etc. Okay, so our common difference here, R, is 3. A is equal to 3, because that's what we start with, and n is 6, because this gives us our 6 terms up here, n equals 6. So I can use the formula here, because R is greater than 2, I'm going to use this formula here, so Sn, okay, I can say is A, which is 3, times 3 to the 6 minus 1, all divided by 3 minus 1. Okay, and I'll leave you to work that out, but that's how you would fill in for that. Okay, another question. This is question 8 of 19E. If U3 is 2 and U5 is 18, find R. Okay, here we have that U5 equals u3 times r squared, because it's the common difference times the common difference. So in this case, 18 equals 2 times r squared, so 9 equals r squared. Therefore r is plus or minus 3. So notice you can get two terms there. And the last question is question 12, what I'm going to do, and then once I've done this, and you can have a go at the rest of 19E, and there'll be one more video to do, and that will finish off the chapter 19. Okay, find the lowest number of terms where Sn is greater than 7.998. Again, we're going to start off writing down what our letters are. A is 4 in this case, R is a half, because I'm multiplying by half each time, and N is what we're trying to find out. Okay, so I can fill this in again here. Sn we want to be greater than 0.7, so we want 4. Because we've got a half here, we're going to do 1, 1, 1, take away a half to the n, divided by 1 minus a half, and we want that to be greater than 7.998. Okay, so this is a half, so a little bit of rearrangement gives me 8, 1 minus a half, n is greater than 7.998. Okay, so that leaves me 1 minus a half to the n is greater than 7.998 divided by 8. Okay, that gives me 1 minus 7.998 over 8 is greater than a half to the n, and that gives me log 1 minus 7.998 over 8 is greater than n log a half. Okay, log a half is negative, so when I divide by that, I've got to change the sign around. So n has got to be greater than log 1 minus 7.998 over 8 divided by log of a half. Okay, this is 11, just over 11. Okay, so I think 11.96. N has got to be greater than that. Therefore, because n can only be integer terms, n has to equal 12, and that's the first term. Okay, so have a go at the odd questions on 19E. If you get any problems, email me, like I said, and you've got one more video after this, which is the infinite series.